And class, now let us have percentile. So if for quartile, it divides the observation into 4 equal parts. Percentile divides the observation in 100 equal parts. And it is used to indicate how much of the observation or the values may be found below. Like for example, if we have 30th percentile, this means that 30% of the observation may fall below it. Say for example, class, you scored 67 out of 90 in a test. But does this value mean something? Yes, you know that this is 67, but how about the position? Okay, this value class has no real meaning unless you know what percentile you fall into. Like if you're in the 90th percentile, if you're in the 95th percentile, and so on. If you solve for the percentile of your score, then you will know your position. So, pila ka kalabaw kaysa sa uban. Sige. We will have some examples later on. Okay. Now, to compute for the position, we have L equals K over 100 times N. So, where K is the kth percentile, then N is the total number of observations. See, L here is just the position, and once we have found out the position, we will identify the value. But we have to take note, class, we have a rule in using this formula. If L is whole number, the kth percentile, the kth, is midway between L and the next value. Meaning to say, the value of the observation in the L position is the average of L and the next value. However, if L is not a whole number, a decimal number, we round it up. Again, we round it up, delete round off, round up to the next integer. Like for example, if we get 5.2, we round it up to 6. If we get 5.7, we round it up to 6, round up. If L is not a whole number again. Okay, so again, that position is the kth percentile. Sige, we will try. For example, the following are the scores of 15 students in midterm exam in Math 11N. Okay, for example, these are the scores of 15 students. We have 85, 34, 42, and until 86. Now, find the 80th percentile and 90th percentile. So we can have 15th percentile, 50th percentile, because again, percentile divides the observation into 100 equal parts. But hindi na nato pangitaw ng first o 100th percentile because the first percentile is the lowest observation, 100th percentile is the largest observation. So here, we could have second percentile, the third, the 99th percentile, and so on. But in this case, let us have the 80th percentile and the 90th percentile. And for number 2, we find the percentile if the score of a student is 85. So what position? Unsa man na position ang iyang score? Okay, sige. Let us have number 1. But again, we need to make sure that our observation must be arranged in ascending order. So we have here the arranged data. Arrange in ascending order. Now let us find the 80th percentile and 90th percentile. Okay, so we have here 80th percentile. We will use the formula L equals K over 100 times N. So our K is 80th percentile. Our N, the total number of observation, which is 15. Okay. Then, using the formula, we have L equals K is 80 divided by 100 times the total number of observation, which is 15. And using your calculator, we have 80 divided by 100 times 50, so you can compute directly. L is in the 12 position. But take note, class, again, that we have a rule. If we get a whole number as the position, we need to get the average. We get the average of the 12th term or observation and 13th observation. Okay. So, we have the 12th term plus 13th term divided by 2. Wait, nahiwi ang line. So, the 12th term is 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. Okay, 86. 86 plus 87 divided by 2. So, we have here 86 plus 87 divided by 2. We only have, yes, 86.5. So, this is the score in the 80th percentile. So, what can we conclude? The score of 85.5 is 80% because we're talking about the 80th percentile. So, 80% greater than, wait, wala siya class. Last viewed. Okay. Here. So, greater than or equal to the other scores. Sa 15 ka scores in this set of data. So, if your score is 85.5%, then you are 80% higher than or equal to the other scores. I hope it is clear. So, that's it. How about letter B? So, let us find the value. The score if the percentile is the 90th percentile. Again, using the formula L equals K over 100 times N. Our K is 90% and our N is the total number of observation, 15. So we have K is 90 divided by 100 times 15. So L is, what is L? 90 divided by 100, we have 0.9 times 15, we have 13.5. Take note, class. Our position is in decimal number, not a whole number. What is the rule? If the position is not a whole number, we need to round it up, round up to the next integer. We need to say the position is 14th, is in the 14th value. So what is in the 14th position? So 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12, 14. So this one, 88. 88. Meaning to say that the 90th percentile is 88. The score of 88. And what can we conclude? So the score of 88 is, again, 90th percentile, is 90% greater than or equal, because it could be, say for example, lahat kayo nakakuha ng 88 or below you, 88 din. So that is why we can say that greater than or equal. Greater than or equal to the other scores. So that's it. Now, say for example, the previous slide, diba, I mentioned that how about if you scored 67 out of 90? So you can actually solve for your position by using the percentile formula. Like for example, if there are 50 students, or say for example, ato gamayon 30 students in your class, and you scored 67 out of 90. Okay, and then you identify on what position you are. Like maybe you are the 10th highest among all, then you can use this formula to identify the percentile. The percentiles. Okay, let us have an example for this. Okay, number 2. Sige, number 2. For number 2, same data set. If the student score is 85, unsa ni siya nga percentile? So find the percentile if the score of one of the students sa kaning 15 ka students is 85. Using again the formula, L equals K over 100 times N. Now, the given, we have score of 85, and then our N is 15. We need to find K because we are talking about the percentile. So, si K. Now, we need to identify the position of 85. So, we just simply follow the arrangement here and then locate 85. Like, say, for example, you can use this one or the other one. Same lang man. So, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, we will use this one, the 9th position. So, L is in the 9th position. So, 85 is in the 9th position. So, we will just simply replace L with 9 equals K over 100 times, or N is 15. So, we can just actually cross multiply. So, 9 times 100 equals 15K. So, K times 15, 15K. And then we have here 900 equals 15K. So, let us commute first, commutative. 15K equals 900. And then we solve for K. So, we divide both sides by 15. So, K is, sige, what is this? 900 divided by 15, we have here 60. And the 60th percentile. Okay. Now, what can we infer about this? What can we conclude? Nakuha natin that the percentile for the score of 85 is 60. Then we can say that the score of 85 is 60% greater than or higher than, greater than or equal to the other scores. But in this case, 60% greater than. Okay, so that's it. So let us have another example. Like, say for example, we have 87. Let's check if wala tayong 87. Okay, wala tayong 87. So, let us have 87. Sige. Our score is 3. Score is 87. So, find the percentile. Again, using the formula, we have L equals K over 100 times N. What is the position of 87? So, 9, 10, 11, 12. Okay, 13th position. So, we will replace L with 13 equals K over 100 times N is 15. So, 13 times 100, this is just 1,300 equals 15K. And then we divide both sides by 15. What is K? Divided by 15. K is 86.67%. As you can see, this is in decimal percentile. Now, in this case, class, we just use an interval. Like between the score of 87 is between the percentile 86 to 87%. So 86% to 87%. Okay. So how will you how will you conclude based from the result? So you can say that the score of 87 is 86 to 87%. This is 2 86 to 87% higher or greater than. Sige, let me use greater than. Greater than or equal to the other scores. So that's it. Okay, nganong ni gamit man tag decimal ng class? Because as you can see, ang ato na ko nga percentile kay yung decimal point man. So you'll just simply estimate the percentile of the score of 87. However, if we could get a whole number, then we could just use the 60th percentile. So let us check. Like say for example, we have here 60%. 60% ang percentile ni 85. Now let us see if we could get 85 as the score. So let us check. So we have L equals K would be 60 divided by 100 times 15. So we have here L is 60 divided by 100 times 15. We have 9 plus 9 term. But take note that we have a whole number. So we need to, we need to get the average of the 9th and 10th terms. As you can see, the 9th term is 85 and the 10th term is also 85. So 85 divided by 2, this is just again 85. Okay, so we have a score of 85. But say for example, class, if this is not 85 and then nag-exam na yung multiple choice, if you cannot see there that 60%, 60th percentile lang, then maybe we could also have this one as 60% to 61%, to be sure. Ay pwede man siya from 60 to 61. So same here, if we could get a decimal for the percentile, ato lang estimate from 86 to 87. If you get 60, from 60 to 61. Para sure. Because as you can see, the check na to, yes, 85 ang ato nakuha. But what if kung 86 ang next? Diba, we could get 85.5. So, dili na siya exactly nga 85 ang score. Okay, mo nang, to be safe, so we will use interval for the percentile. So, that's it. If your score is 85, then your score is 60 to 61% greater than or equal to the other score. So, let me just change this one. We have 60 to 61%. Okay, greater than or equal to the scores, to the other scores. Okay, so that's it for percentiles. I hope that you learned the concept of percentile. Now let us have box and whisker plot. So box and whisker plot is also a useful way to present the data visually. So what do we mean by a box and whisker plot? So box and whisker shows the median, the quartiles, and the extremes for a numerical set of data. So the box portion contains about 50% of the data values. The two whiskers each contain about 25% of the data values. It shows how spread out the data values are. They are useful for comparing sets of data. So actually class, kasi box and whisker plot could be under measures of variation, but then ako ni siya i-present ninyo under relative position because we will be dealing with quartiles. Okay, so we have here the box and whisker plot. Again, it shows the 5-number summary of a set of data. We have the minimum value. We have the lower quartile. We also have the median, the upper quartile, Q sub 3, and then the maximum. So as you can see, we have a box here. So the box here is 50% of the data. Then we have the minimum. So from minimum to Q sub 1, 25%, Q sub 3 to max, 25% also of the data. So a total of 100%. Okay, so the red line here is the median. Now, how to draw a box and whisker plot? Okay, so we have here the following steps. Step 1, of course, we place the data in order from least to greatest. If we have a set of data, we arrange them in ascending order. Then in step 2, we find the lower extreme and the upper extreme, or the minimum and maximum value respectively. These are the endpoints of our whiskers. Okay, so whiskers, this part here, whiskers. Okay, so in the box, that is why box and whisker plot. And after finding the lower extreme and upper extreme, of course, we need to find the median, or the second quartile. And we find the lower quartile, the Q sub 1, and upper quartile, Q sub 3. And finally, we draw the box and whisker. Okay, so using the same example on the previous topic on quartiles, okay, let us try to draw a box and whisker plot. And again, this set of data are the ages of the 18 random students in a certain university. So Q sub 1 is 20. We have 20 here. Q sub 2, or the median, is 25. Q sub 3 is 27.25. Okay. And we know that the minimum value is 18. The maximum value is 30. Okay, so again, step 1, we need to find we need to arrange the data set. As you can see, arrange na ni siya in ascending order. And then for step 2, we need to find the lower extreme and on the upper extreme, or lower extreme, the minimum value. And we know that this is just 18. And also, we have the upper extreme, or the maximum value. We have 30. And after this, we find for the median, or Q sub 2, we know that Q sub 2 is just 25, right? The previous slide here. So 25 is Q sub 2, Q sub 1 is 20, Q sub 3 is 27.25. Okay. So we have here, again, our Q sub 1 is 20, and our Q sub 3 is 27.25. So, kani ang gikinahanglan for us to draw the box and whisker. And step 5, we now draw the box and whisker plot for this set of data. Now, class, to draw the box and whisker, we need to create first a number line. I hope na straight ni siya. Okay, so please use a ruler para straight ang inyong box and whisker. So suppose this is a line, and then we just simply label the line where naano siya nga mga values. But then since we started with 18 to 30, maybe we could use 5 units. Mga 5 units na multiple of 5 ang label sa ato ang line. Say we could start with 15. Since ang ato ang smallest value is 18 man, maybe we could start with 15. Then after that, by 5, so we have 20, we have 25, and 30. And ay, 15, 20, 25, and 30. Sige. Ato patasan-tasan gamay para. So we have here 20, 25, and then 30. Now, class, after making this line, we need to locate the median. We know that the median is 25. So this part here, 25, just draw a vertical line here. So this is the median. And then after that, sige, let me use another color. Okay, so median. Ay. Okay. So median here. And then we also locate the first quartile and the third quartile. Our Q sub 1 is 20, so just draw also a line here. And then we have Q sub 3, 27.25. So if this is 27.5, maybe somewhere here, just estimate, this would be 27.25. So 27.25. And then you draw a line also for Q sub 3. And then you form the box. So this is the box, Q sub 1 to Q sub 3. And I will just use another color for the median class. Say we have color yellow. Red na lang. Okay, so this is the median. Okay. And now, since na naman tayo median, we also have Q sub 1 and then Q sub 3. Let us now locate the lower extreme and upper extreme. So lower extreme is 18. So 15, 16, 17, 18, 19. So somewhere here, it's 18. 18. And we draw a small vertical line. And then from lower extreme, we just simply connect it to the box. So this will be our left whisker. Okay, and also we have the upper extreme 30. Since na naman tayo 30 dire, just create a short vertical line and then you connect it sa box. Connect sa box. So this would be the other whisker sa right part. Now let us label our box and whisker class. So again, this is the lower extreme, the smallest value. We have Q sub 1, Q sub 3. And this is the upper extreme. Okay, maximum. We just use maximum value. And then the other one, this is the minimum value. Okay. So this is now the box and whisker plot for this set of data. Now, how to interpret this box and whisker class? Okay, so we have here in the next slide. So just examine first the box and whisker, and then we will try to compare kung asa dapat nga type sa kani presentation ang similar sa kani nga solution. Okay, so as you can see, if we have here, the median is just the center, nasa sa center of the box. It means to say that the distribution is normal or symmetric. Diba? If you could remember, if we have symmetric data, the mean is just equal to the median and also equal to the mode. So we have symmetric data. However, if we have our median is close to the left part of the box class, and then mas dako-dako ang diri sa right part sa box. Again, this is from Q sub 2 to Q sub 3. So as you can see, the distribution is skewed to the right. So something like this. Kana. Okay, skewed to the right. So diba, if you have this kind of distribution, the median is greater than the mode, but less than the mean. Okay. So that's it. So positively skewed to the right. However, if we have skewed left, negatively skewed distribution, so ang median nato is closer to the right part of the box. And then, mas dako-dako, mas dagan ang values from Q sub 1 to Q sub 2. Okay. Again, ang ends atong whisker sa left kay ang minimum, sa right kay maximum. So in this case, we have skewed left or negatively skewed distribution. So, what can we infer? Sa skewed to the left, okay, daghay, mas dako nga values. Yes, dako nga values. And then, we have, kani siya, plus, we have extreme values diri sa left part. But, that is why we call this one skewed to the left. But if you have skewed to the right, we have extreme values sa right part. So, if we go back to this one, sa atong create ng box and whisker, the data is what? Is, kitanawa, negatively skewed. Negatively skewed distribution. Skewed distribution. So that's it for box and whisker plot. Okay, so I hope man it is clear to you, the box and whisker. Okay, so that's it. I hope you learned something. Enjoy learning. Bye-bye.